Okay, I think I'm live. Yeah. Hi guys. If anyone is watching, I'm pretty sure no one is. But yeah, hi. Uh, Today we are gonna go over some basics. Yesterday we just wrote the smart contract for our account contract, which is a term. Like you can go on this link, eips.ethereum.org/eips/eip dash 4337, and then just check your account contract interface. But let's go over some basic today. What is ERC 4337 and how does it actually work? Okay, so as you can see here, like account abstraction using alt mempool, an account abstraction proposal which completely avoids consensus layer protocol changes, instead relying on higher layer infrastructure. So in general, like what is account abstraction? Account abstraction is basically separation of validation from the execution. So how things get validated and how things are executed on blockchain. So let's understand one thing. We have EOS on one side and then smart accounts. Let's name them smart accounts. Smart accounts EOS. Let's maybe, yeah. So this is like your your general wallet, like MetaMask or Phantom or something else you like. So how the validation and execution works here is that you sign a transaction and send it over the network. Send it on the network to get executed by a smart contract. This is a general flow, but you can't remove the validation phase and execution phase. Like you only need to send this. You only need to send this transaction over the network. As for signing the not signing, like for sending the transaction and making sure it is you, it needs your private key. And we all know, like you shouldn't send your private keys to anyone else, as it's like a issue. Let me change this to dark mode. Yeah, this is still visible. Okay, so here, like you have only one one mode of validation, one like way to validate a transaction, that is private key, and only you can send it over the network. Which requires gas, like the ETH or whatever it is, like what can I, Sol or BTC, whatever it is. But with smart accounts, it is a smart contract. It's not a EOA. It's not a EOA, like externally owned account. Instead, it's a smart contract written in like Solidity in our case. But what is its like important features? So as we saw yesterday, like in ERC 4337, there is no transaction object. At least when you think of how transaction works, like there is no transaction objects for user. There is a transaction happening in the background to send that user operation over the network to get executed, but you won't see that like on the user interface. Instead, it will be something different. So how this like we talked about like validation from execution. So with smart contracts, like you're not limited to using private keys. Like in our account contract, our simple account, let's say we are using ECDSA signature to validate the user op, but it can be anything else that you want. Maybe like a social login like Google or Facebook, let's say, or like biometrics, which is like your fingerprint or face, like face scan. I don't know what it is called, but like unlock with your face, how we have in all smartphones. Next, so this is like we separated how we can implement like custom validation logic here. So after that, the execution part of the user op, that execution execution will happen simultaneously after the validation is complete. But the part where you have to send the transaction over the network and spend gas fees, that's removed here. Like user operation is sent by something called a bundler. So we saw this like title, right? Using alt mempool. So what is alt mempool? Alt mempool is just like bunch of bundlers talking with each other. If you think of like, let's go somewhere else. Yeah. What is mempool? What is mempool? Mempool is just bunch of validators talking with each other like mempool is, let's say, yeah, mempool is where transaction go before they get executed. And this mempool, like any other validator on the network, like if in case of Ethereum, any validator on the network like can see can have their own mempool, and other validators will like get the transactions from that mempool and try to execute it if they are the one who are like proposing the block. So it's like a pool of transactions where transactions stay before getting executed and included in the network. Okay, so this is same. Then let's see, like, what is alt mempool? It's very similar. Let me check. Okay, so pool of user operations. Where user of stays before getting validated slash executed and included in the network. But this is not the validators. This is network where all the bundlers stay. So let's see here, like this is v1 validator 1, let's v2, and these guys talk with each other. This is, let's say, like a barrier, and then there is another mempool which is bundler 1, let's say b1 and b2. They will talk to each other, and whenever one bundler gets like a bunch of user operations, it will create a transaction and send it to the validator to get executed, and the validator executes it, like puts it on the blockchain, and the actual entry point interaction happens there. So that's the ultimate pool. This is the higher level infrastructure. So base layer is like the validators that are talking with each other and having all the mempool, all the transactions in the mempool, and there is one layer above that which is layer of bundlers, and that's what called a alt mempool instead of actual mempool. Like, we don't want everything things to be confusing, so that's why the team who designed the ERC 437, they called it like a alt mempool instead of mempool, because it might be confusing to some. Now let's go to user operation. We have seen like the user operation in the yesterday's image. So how the flow will work is, there is a user. There is a user who will like sign a user op, user operation. Let's put it here, which goes to bundler. Now we have this bundler. Bundler sends it to like validator, but we can abstract that. It goes to entry point. Like what validator does, it puts it on the network to get executed. So that transaction will interact with entry point. This sends like array of user operations. This will be here, array of user operations, and then we'll have like account contract 1, and let's like copy it multiple times to show like there are multiple account contracts. 3. So let's assume like there are 3 example. There are 3 user operations in this array. So first operation like will be executed on this, then second will be executed on this, third will be executed on this. So the user operation that we saw yesterday, which was here, this is a user operation, but it is called packed user operation instead of like, yes, a regular user operation. Let me just paste it somewhere here. Yeah, so sender will be the address of the account contract, then nonce is same as how it is in the transaction to prevent like replay of signature attacks, which you can read it on internet anywhere, like you will understand what it is. Then init code, like we'll go over that sometimes afterwards. Then call data, you understand like it's a call data to execute a function or do some on-chain activity. Then gas limits, pre-verification gas fees, all these things, fields are gas related fields. They are not same. They are not same as like transaction, but they are similar. Like pre-verification gas, this will be different, but gas limits are same. There will be base gas fee and the priority gas fees. Then gas fees will define the fees per gas, like how much gas fees per unit of gas you are willing to pay for both of the fields, like the base gas fees and the priority gas fees. So these two things. So similar to EIP 1559, there are two, like we'll define two things here, and then we'll see what happens. But these two things will be included in this one field, and call gas limit and verification gas limit will be included here in the account gas limits. Paymaster, we don't really need to care. Signature, we saw what it is. Yeah, let's go over user operations. So if you see in the EIP, the user operation is something different. Like it's not similar to what we saw on this, right? In the struct. So why is that? If you scroll down, you'll see like this is the original user operation, but it will be packed and then sent it to the entry point contract. So we need to keep all these things in mind. Like each of the fields has some data. Like some use for all the operations that will do in the future. So init code is like combining factory and factory data fields, then account gas limits is concatenating these two, like verification gas and call gas. Pre-verification is not doing anything. We'll learn like what it is. It's basically for bundler. Then gas fees, we are combining these like max fees and max priority fees and max fees per gas, and then creating this new value. Paymaster, we are combining multiple fields, 1 2 3 4 fields into one, and then sending it to entry point. And signature, it's similar like ECD as a signature. Now that we understood this basic thing, basics like of ERC 437, we can go to next part, which is testing the contracts that we wrote yesterday, which was simple account. Why that was important? Because we are going to write a test where we are getting a what's it called, where we are sending a entry point, where we are sending a user op to entry point, to smart account via entry point. So this whole thing will happen, this flow. Instead of bundler, we won't have bundler like software running, but let's like assume this is also address, like it is a EOA. Bundler is EOA, and it is sending the transaction. So we can just create a dummy account to test the thing, test the whole flow. We are going to run our bundler software. This bundler software, like there are multiple. There is like rushed bundler from Alchemy. Then there will be like ETH infinitism. If you saw in this repo, there is a bundler. Yes. So this bundler is basically a software which has its own RPC endpoints, and it interacts with the validators and like sends the user operation to get executed on chain. So we are going to run this on our local and show it, but it's not right now. Right now we are focused on testing and writing the contracts instead of actually like instead of going deep on the whole process. We are first gonna understand like high level things, basics of all the processes and like entities involved in the account abstraction flow. So this flow, and then we are going to like go deep on each of them. But first we need to understand like everything, then only we can go deep on each of them. Okay, so we can start with testing the contracts. Where is our test repo? Yes, test, not test repo, tests folder. Let's create a new folder called unit, and in test we are going to create one more called integration. In unit, create a new file called simple account test.t.sol. Okay, similar to entry point, like we can just copy this pragma directive and paste it here. Then if you are familiar with foundry testing, like how foundry tests work, is basically we'll create a new contract, we'll name it similar to what we named the file is test, and it will import the tests contract from Foundry's standard library. It has multiple like functions that will help us test the contract. Now we'll import that tests contract from forge std/test.sol. Yes. Okay, what's the issue here? Okay, yeah, resolved. Okay, then each test contract will have a setup function where we'll like create the conditions for our tests. Setup is basically you can do whatever and it'll run before each test. It is like a hook similar to before each in the hard hat framework, if you are familiar with that. Now what we need to do, we need this is a unit test, so let's like write some title notice. No, okay, title unit tests for the simple account contract. Notice what does it do. No, title explains it. So we are unit testing the simple account contract. We can write it better like simple account we are going to write simple account, and then we might also mention like source/sample sample/simple account.sol. So just if someone else comes in, we can tell them like where the fuck this thing is. Now first thing first, like we need an instance of simple account and entry point. So why, like simple account we need it for testing, and entry point we need because we have this thing like required from entry point, right? So required from entry point needs an entry point. right now we don't really care because it's a what it is called, like, as a unit test. So we can just create a random address and tell the test that this is the entry point. In integration test, that won't be we can't do that, but in this case we can. And so we can test multiple things here. We can test entry point function. We can test execute by just like using something called prank, which comes in with the test, like using the tests. We are using the test contract from Force standard library, and the prank function comes with it, which allows us to tell the function that next call that will be made in the test is from particular account, which is explained, which is given here. Now okay, so let's start with like importing the import simple account from source/simple account.sol. No, source/sample/simple account. Yes. Now we can create simple account private simple account and address private entry point. We can create like simple account. Let's first create the dummy entry point address. Entry point equal to mac addr entry point. So this mac address, this function comes with the test contract, or I think from the VM, which is, I don't know if, yeah, it's VM. Let me check. Control F. Mac. What is Mac? No, not from VM. Then standard utils. No. Maybe we can just check here. Yeah. So okay. So MAC address is the cheat. It's not cheat code. So let me switch here. Yeah. Get book.get foundry. We have a section called cheat code references. Yes. So all the cheat codes we can use, and MAC address is one of them. This generates random address from given string. We don't really need to understand how it works in the backend, but whenever you send this string, a particular address will be generated. It will be same, hopefully, for all the tests. It will be same, but I don't know if we use this in multiple tests, it will be same or not. I haven't checked, but We'll check in the coming tests if it's same, if it varies. If it varies, we don't really care. In this contract, it should be same, and it will be. The next is creating an instance of simple account, which is similar to like simple account, and then this is the main thing, which is sending an address, sending an entry point, like I entry point thing here. So let's import I entry point interface, because we need argument of type I entry point to create a new instance of simple account. Source slash course, no, source slash interfaces slash I entry point dot sol. Let's see now. I don't know if we can generate like I entry point and just put like entry point address here. Will that work? And then message dot sender. Yeah, that works. I wrote my tests in a different way. Previous test. So previously in the Medium article I wrote, instead of taking I entry point as an argument, I took address as an argument and created like similar to that. Like I created entry point equal to I entry point address. So that's different. But in our case, that this should satisfy. Message.sender is the address of this contract. It is deployed on the local chain while testing like the instance that Forge creates. Now we can write our first function, first test. We'll test if the entry point address is correct or not. Now, what is this thing? Yeah, function. Each test should have test at the start of it. So test underscore and then whatever you want to write. Test underscore check if entry point address is correct. External. Now, how do we check that? We can check it by calling account dot entry point. This will return us value of type I entry point. So we'll typecast it to address. Now this is done. We can assign it to a variable address entry point address equal to the thing. Okay. Now next part is assert. We are going to assert equal to. Like we are gonna, let me see. Okay, this doesn't work. I don't know why it's not working. Assert equal to definition, but it should be somewhere. Let's check here. assert equal to. Okay, in the standard assertions we have this assert equal to. So we can check anything with it, like assert equal to left address and right address. So if they are same, the assert equal to will work, otherwise it will revert. So we have the entry point address. This refers to this entry point, and then we have entry point address, which is from here. Okay, spelling mistake. ASS assert equal to. And last thing is we can restrict this to view, as we are not making any changes here. Okay, now we have written this test and we can just run forge test. As you can see, it is passing. We can see like debug trace maybe and see what's happening. So as I said, like setup, it starts here, like it creates this entry point, then creates a simple account, and then transfers ownership. Like this is internal function. When, let me show you. Here we are doing ownable, right? And ownable, this initial owner, transfer ownership, old owner. So yeah, old owner, there was no old owner, so this value, the address default value for variables of type address is 0. So that's why when it checks like new owner, old owner, and sets like whatever the old owner is, it stores here, then changes underscore owner to new owner, the address we sent, and then emits the event. That's why we got this thing, address 0 and then the new owner. This is our contract, basically the test contract. Now next thing is here we are doing a static call to get address of an entry point. Not address, we are getting value of type I entry point, and then we are type casting it to address, and then checking if entry point is equal to entry point address that we got from the simple account, from our account smart account contract, and it works. So what is the next thing we can do? Next thing, let's ignore this because it's internal. We don't really know how to test it right now. Like I do know it, but we are gonna do that afterwards. This thing, we can test this. This is an external function, so it won't need anything else. So let's test if function test if execute works properly. Then we can give like external. So what we want to do here, execute will will create what do we call execute will execute the call data on the account contract. And in the call data, we are expecting these three things: one, 2, 3. We don't really need to construct the call data right now, but we can just call this. We can assume entry point is constructing that, and we'll learn how to do that in the integration tests. But right now, we need to prank the execute call and tell it that this is from entry point. So to prank, we need to vm.prank and do something like vm.prank entry point, then simple account dot execute. But what we want to do in the execute, we don't really have anything else to do. Like we don't have any other contracts to test. Like we can't do trades, we can't do anything. So let's this call will the test call will send some ether from account contract to some random address that we created. So similar to how we created address with mk make address in above section here in the setup function, we'll create address random address and pass a string. This is not here we are just checking here we are creating a random address so that we can send some ether to that particular address from simple account. But one more issue is there. If you think about it, this is test and we don't really have anything in simple account, no ether. So for that we can use deal. It is another cheat code. Deal is basically we are giving some ether to any particular account or address for test purposes, not for regular use case, but this is for test purposes. Simple account, we can we first need to typecast it, simple account, and then we need to tell how much ether we need. We can tell 10 ether, it doesn't matter. Now what is destination? Destination is our random address. What is the value? We can send 1 ether, we have 10, we don't really need anything else. And then what is call data? There is no call data as we are just sending ether. Now this is just blank byte, 0 bytes. This should work, but how we are going to test the actual ether change? Is there a ether change? We don't know. We need to check. We need to have initial balance here. We don't really need to have initial balance. Whenever we create an address, the balance will be 0. As we are sending 1 ether, we are going to check if assert equal to simple account dot balance equal to 9 ether, 10 minus 1 9, then what is okay, sorry, we need to typecast it to address, and then random address, ether valence should be 1. And that's about it for this test. Let's see, does this work? If this works, like the ran we know that this execute function works and it is from entry point. Like if it's not from entry point, it should revert. We'll see like in the next test how to test it. But right now we are assuming we are uh, we are assuming that call will be sent from entry point to simple account uh, execute function with these values. And as we know, like we have 10 ethers, random address as 0. If this works, this line 33, then the balance, our balance will be, the simple account balance will be 9 and the random address account will be 1. Now let's run forge test. Yes, as you can see, test if execute works properly. It is working properly. Now there is one more thing called coverage. We have a lot of red lines right now. We don't really need to think about it. All these core libraries, like core contracts, we are going to test it, just not right now. Instead, we are going to go over this. So we have tested 45% of the line, 40% of the statements, and 0% of the branches. So what is branch? We have, how many branches we have? We have 3. So if you see here, like this is any like branch of conditional, it is considered here like branches. Like if there is a condition, go here and else go here, like it is branching out. That's why it's called branches. So we are going to go over each of them, but let's like write our next test, which is function test if not called entry point execute reverts. External, here we know, like we are going line by line. First everything works, that was the assumption. So entry point, this won't fail. This is successful, and there is no false flag return from this call. So we won't see this error, which we didn't see. Now we are going to call it from a random address, call the execute function from random address, hoping that there is a what we call a revert from our account contract, and it will tell us like, no dude, this is not the thing I expected, and it's going to return this error. So just we can copy this. Next is, let's write the function. Simple account dot execute, and then we can just copy all these things. And we can also copy this. Like, you don't have to be redundant. Like, we can write these tests better. We'll understand. We'll refactor those afterwards. But now we'll learn about one more thing. vm.expect revert. What is expect revert? Let's go to let me stop this timer. Let's go to this, the book, Foundry book. Expect revert. This is another like cheat code. Expect revert. So what expect revert does is, whenever you call a function here, like we are calling this function, or there is any call, it tells the test like there will be a revert, and if it reverts, the test is successful. If it didn't revert, test is not successful, because that was not the condition, or what you can call it, that was not the expected result. So we are expecting a revert with, no, not this. What was the error? Yeah, account not from entry point. This was the error which we'll expect. If our assumption is correct, we'll get an error of value this. We are putting it in bytes because it's so that like the Forge can understand. Now we can run test and everything should be green. Yes, it is. So when it is not called from entry point, it reverts. When it is called entry point, it executes perfectly. So these are the things. These are the basic things. Now we still have multiple things to do, like go over this, and we still haven't worked on our actual validation function, which was the core of our simple account, because this is where validation happens, and if validation happens, then only execution happens. But this is an internal function, and we can't really call an internal function from external contract, right? So how can we test it? Okay, we are not going to test that today. We are going to test it like tomorrow and see like what happens. See how to do that. But for now, like, you can just go and check this, or go on my GitHub and see all these tests. And tomorrow we'll go more deep into unit tests and see like how to test internal functions, and how to see like how to how to test like these calls which are failed. Like, how can we fail this call to get false value here, so that this thing this so that we can get this error instead of not getting an error. So we'll learn that tomorrow, but for now I think we are good to go, and see you tomorrow. Bye bye.